Let's solve two more problems on successive differentiation. The first says evaluate the square y e theta squared when theta is equal to 0 given y is equal to 4 sec 2 theta. Okay, and given y is equal to 2x exponential minus 3x, we should show that the square y dx squared plus 6dy dx plus 9y is equal to 0. So let's start with the first one. We're given that y is equal to 4 sec 2 theta. Now, how do we go about differentiating a sec function? Now, we recall that sec or sec theta, as the case may be, is 1 over cos theta. Okay, therefore y, which is 4 sec 2 theta, can be written as 1 or 4 over cos 2 theta. Now, to solve this, we go back to our quotient rule. So therefore we have this to be u and we have this to be v. And if you recall from quotient rule, we have that the y dx is equal to v du dx minus u dv dx divided by v squared. Now, if our u is 4 and our v is cos theta, now notice that the variable we are differentiating with respect to here is theta. Therefore, our du d theta is equal to 0, and our dv d theta here will be minus 2 sine 2 theta. Because when we differentiate cos 80, we are going to have minus sine 80. Now let's apply dy d theta is equal to v du d theta minus u dv d theta divided by v squared. So let's make our substitution. We have cos 2 theta multiplied by du d theta, that is 0, minus u, that is 4, multiplied by dv d theta as minus 2 sine 2 theta divided by v cos 2 theta squared. So this turns to 0, and thereafter we are going to be left with 8 sine 2 theta divided by cos square 2 theta. And solving this further, we can rewrite it as 8 sine 2 theta over cos 2 theta multiplied by 1 over cos 2 theta. So we can write our dy d theta to give us 8 tan 2 theta sec 2 theta. Now, to differentiate further to attain d square y d theta squared, then we are going to apply product rule, where we have this to be our u and we have this to be our v. So if u is equals to tan 2 theta, 8 tan 2 theta, and our v is equal to sec 2 theta. Okay, then our du d theta is going to give us 8 into 2 sec squared 2 theta, because when we differentiate tan 2 theta, we have 2 sec squared 2 theta. Differentiation of tan a theta or tan ax is equal to a sec square a theta, and this will give us 16 sec square 2 theta. And thereafter, let's evaluate the v, the theta. Now, if you see from our first question, that's when we evaluated 4 sec 2 theta, we arrived at this 8 tan 2 theta. Therefore, the differential of sec 2 theta naturally will give us 2 tan 2 theta sec 2 theta. Thus, applying product rule, we have that dy d theta will be equals to dy, equals to v or u du d theta plus u dv d theta. Therefore, we can make our substitution. Our v known to be sec 2 theta, our du d theta known to be 16 sec square 2 theta, our u, which is 8 tan 2 theta, combined with 2 tan 2 theta sec 2 theta. Now, if you open the bracket, we have 16 sec cube 2 theta plus 16 tan square 2 theta, okay, multiplied by sec 2 theta, and this is d square y d theta squared. Now, the question says evaluate this when theta is equal to 0. So we make our substitution. When theta is equal to 0, we have that d square y d theta squared at theta is equal to 0 is equals to 16 sec cube of 0 plus 16 tan square of 0 and sec of 0. Cosine of 0 is 1, so sec of 0 is 1. Tan of 0 is 0, and sec of 0 is 1. So this will give us 16 plus 0, and it will give us what? 16. Now let's go into the next question. And from the first one, we can see that we applied product rule and also quotient rule. Let's take a look at the second question. It says given we are given y is equals to 2x exponential minus 3x, and we are asked to show that d square y dx squared plus 6 dy dx plus 9y is equal to 0. Now, arriving at this, the first thing we to do is to evaluate dy and to evaluate dy dx. So we see that this is a product, u and v. U is equals to 2x, v is equals to exponential minus 3x. So du dx is equals to 2, and dv dx is equals to minus 3 exponential minus 3x, because when we differentiate with respect to x of exponential ax, we are going to have a exponential ax, and in this case a is equals to minus 3. Now let's apply product rule, and product rule says that u dv dx plus v du dx. That's 2x multiplied by minus 3 exponential minus 3x plus exponential minus 3x multiplied by 2. Now this is going to give us minus 6x exponential minus 3x plus 2 exponential minus 3x. And this is our dy dx. Now we want to differentiate further to evaluate the square y dx squared. Now we can see that this can be differentiated normally, okay, without any product rule or quotient rule. However, this must be differentiated using product rule. Okay, so we can call this our u and we can call this our v. So trying to do everything in a straight line, you can say d square y dx squared, or rather before then, if our u is 6x minus 6x and our v is exponential minus 3x, then our du dx is equals to minus 6 and our dv dx is minus 3 exponential minus 3x. So let's apply product rule here and then we will sum it up to this. So d square y dx squared, applying product rule, let's start with v du dx plus u dv dx. That's exponential minus 3x multiplied by du dx, that's minus 6, plus u minus 6x multiplied by minus 3 exponential minus 3x. Now we have been able to differentiate this using product rule. Now we can now differentiate this, and that will give us plus 2 into minus 3 exponential minus 3x. Now let's simplify further. So this will give us minus 6 exponential minus 3x plus 18x exponential minus 3x and minus 6 exponential minus 3x. So in conclusion, our d square y dx squared is 18x exponential minus 3x minus 12 exponential minus 3x. Now remember, we are asked to derive or prove that d square y dx squared plus 6 dy dx plus 9y is equal to 0. Now with this done, we have to make our substitution of d square y dx squared and make our substitution of dy dx. And we know this is the d square y dx squared, and our dy dx that we calculated earlier is given as minus 6x exponential minus 3x plus 2 exponential minus 3x. Now let's make our substitution. Starting with d square y dx squared, we have 18x exponential minus 3x minus 12 exponential minus 3x plus 6. And let's make our substitution of dy dx as minus 6 exponential minus 6x exponential minus 3x plus 2 exponential minus 3x plus 9. And let's make our substitution of y. Our y in the question is given as 2x exponential minus 3x. 2x exponential minus 3x. Now this should give us 0. Now let's prove that it's going to give us 0. So let's open up the bracket. So we have 18x exponential minus 3x minus 12 exponential minus 3x minus 36x exponential minus 3x plus 12 exponential minus 3x and plus 18x exponential minus 3x. Now 18x exponential minus 3x, 18x exponential minus 3x will give us what? 36x exponential minus 3x minus 12 exponential minus 3x minus 36x exponential minus 3x plus 12 exponential minus 3x. Okay, now this will nullify this. Likewise, this will nullify this. So our final answer is 0. So hence, when y is equal to 2x exponential minus 3x, we have been able to prove that the y dx squared, the square y dx squared plus 6 dy dx plus 9y is equal to 0.